Hi everyone and welcome back. Today we are going to solve the lead code problem count submatrices with equal frequency of x and y. We are given a 2D character matrix where each element is either x or y or dot, and we need to return the number of submatrices that contains the top left element, an equal frequency of x and y, and at least one x. So again, we are given a grid filled with x, y, and dot. And our goal is to count submatrices where the number of x's equals the number of y's. And also, the submatrix must contain at least one x, and the top left element is included. So here we need to track two things at the same time. First, the balance between x and y, and to do so, we will treat each x as +1 and each y as -1 and the dot as 0. Second, we need to know whether we have seen at least one x inside the submatrix. So here is the key idea. We will use a 2D prefix sum matrix, and at every cell we will store two things. First, the total balance from the top left corner. Second, a flag that tells us if we have seen any x. Why this will work? Because at or for each position, we can instantly know if the number of x equal the number of y, and also we will know does this submatrix contain at least one x. And if both conditions are true, we will count it as a valid submatrix. So again, here is the strategy. At each cell, we convert x to +1 and y to -1 and the dot to 0. Then we update our prefix sum matrix using our classical formula, which is to calculate the prefix sum at the current cell. We will do top plus left. Top means the top cell of the current cell and the left cell of the current cell, minus the top left cell, which is on the diagonal, plus the value of the current cell value. Now for the second part, we need to track if we have seen any x. So to do so, if we are in the current cell, then we will check if either the top or the left or the one on the diagonal side is x or not. So if any part of the submatrix contain an x, this flag for the current cell is set to true. After that, it comes the important check if the balance is 0 at the current cell and we have seen at least one x, then we mark this submatrix as a valid submatrix and we count it to our result. Now, let's walk through a real example. Imagine that we have an input grid. It looks like this one. Let's put it above each other. And we need to fill our prefix sum matrix. And so now let's move it to the code. So instead of writing the code line by line, I'll paste it and explain it line by line for the sake of the time of this video. So first I stored the grid sizes in two variables, n and m, where n is the row size and m is the column size. Then I created the prefix sum matrix. It's 2D array, and at each cell we store two values, a pair of integers, as we have seen here in this example. And after that, we define an answer variable that will hold the final result. And then we iterate over each and every cell in the matrix and define an integer val that will store the value that will be either 1 or -1 or 0, depending on the current value of the current cell. So if the current cell is x, the value will have 1. If it's y, the value will be -1. And if is anything else, which is dot, it will be 0. After that, for the first element of the pair here, I will set, keep in mind, I have defined my prefix matrix to be one, uh, one extra, or n plus one and m plus one, and that will help in preventing checking for condition that I is greater than 0 and j is greater than 0. That will make the code looks clean and neat. So that's why I defined the sizes of the prefix matrix as n plus 1 and n plus 1 and m plus 1, and define the default value to be a pair of 0 and 0. So we will start at the cell I plus 1 and j plus 1 and setting the first element. And that here we apply our famous formula, this one, that we add the top element plus the left element. Here, this is the top element plus the left element minus the top left element plus the current value. And for the second item in the pair, we do an OR operation here between, again, the top element and the left element and the top left element. And finally, we check if the balance is 0, That means that this cell is or this submatrix is partially valid, and also we check that we already have seen an X, which is stored in the second of the pair, and if so, we increment our result. And finally, we return our result. So as you can see, no brute force here, no missing edge cases, just a clean code that runs in O of n multiplied by m solution, where n and m is the size of the matrix. So let's run it to make sure that it's an error-free, and let's submit it. So this is the explanation for today's problem. So if you like it, don't forget to like and subscribe for more problem solving solution and lead code problems. And see you in next problem. Happy coding. Bye.